And now is a good chance to actually see the real product, the real service that we are developing based on Windows Azure, Live Identity Framework, and Geneva. So this is going to be a 400-level session. I kind of assume that you are somewhat familiar with ASP.NET, Windows Communications Foundation, and have basic understanding of what Windows Azure is, what Geneva is. At the same time, we are not too crowded, so whenever you have a question, just raise your hand, interrupt me, so I don't go into like somewhere deep where you don't just get the basics. Kind of introduction of who I am and what you're going to see during this session. So my name is Dmitry Sotnikov, and I work for Quest Software. Quest Software is a Microsoft ISV partner developing software to manage Microsoft infrastructures, AD, Exchange, SharePoint, you name it. And this is not consumer-oriented development, not consumer applications, but kind of enterprise applications, systems management applications. We are not the next Facebook creator. We are creating tools to do backups, manage identities, and so on. At the same time, today, with the current on-premise technology, our software requires people to set up their SQL, set up their SQL reporting services, maintain all that infrastructure. So for small, medium size of business, being able to deliver the same functionality as software as a service sounds like a very good model. That's why we got interested in Windows Azure and tried to develop something. But first, the word from hello from our legal department. Basically, that's saying that whatever you're going to see next is the stuff that we're developing, but there's no warranty that it's going to be in production the way it's going to be demoed, blah, blah, blah. Let's all mentally click I accept and move to the next slide. So the biggest challenge that we had when we started thinking about moving our products into the cloud was that our products were never designed for that. All our products are traditional on-premise products. You get the setup, you get the license key, you deploy SQL, Windows Server, SQL reporting services, then you deploy our product, you set this all up, you wire this together, and then you take care of all the security, you take care of maintaining that, etc., etc. So when you try to provide the same functionality from the cloud, you need to do a lot of stuff that our developers just never had to implement, right? They never had to do billing. They never had to let customers manage subscriptions. They never had to provide multi-tenancy and ensure security across the internet. They just never had to think of these tasks. So what we are trying to do is we are trying to build that common framework that then we'll be able to provide to each of our teams so they can just take their product-specific code. For example, Recovery Manager for Active Directory is our AD backup recovery tool that's likely to be the first one to be plugged into that and use that common framework. So today we are going to see how that common framework works, and we'll be looking at the blocks that are marked as italic on this slide. So we'll be looking at how web portal works, how licensing works, authentication, authorization, and the whole agent infrastructure, secure collaboration. And the scenario which we are going to see is the following. It's on the screens right now. So basically, the first step is that customer comes to your website and logs into that website. We will eventually be providing a few options for them to log on. We don't want to store their credentials and maintain all that. So the few options that we will be providing is Live ID. Live ID is going to be great for especially SMBs, small businesses. Everyone in Microsoft Space has a Live ID, so why not let people use that? And then the other one, which we will be providing later on, is AD integrated. So if people have Geneva Server on their on-premise in their network will be able to just use the AD credentials. But in this particular demo later today, we'll see how Live ID is used for that login. So customer logs in, then registers. We see that that's the first time this person appears at the website. So we ask for normal information. What's your company? What's your email address? What's your phone number? And your pet's name. And your wife's phone number as well. So, I mean, we know when the guy is at work, right? Because we are tracking all that they're doing. So after that, when they provided all of that, then we need to store that somewhere. So where do we store that data when you don't have a local database? Well, we are running on Windows Azure, so we'll be using Windows Azure storage, specifically table storage, to persist all of that data. So we'll see how we are doing that. So once that is done, then we need to actually put an agent on the client side, because this is not a pure web application. We actually need to do, say, Active Directory backup and recovery. So how do you back up a domain control if you don't have something within the network? So then just giving an agent sounds like a simple idea, but then you need that agent to actually communicate with your cloud in a secure fashion. And you need to know from which particular organization the agent comes. So you don't give access. You don't give that agent access to, say, someone else's storage. So there's the whole set of tricks here. You also need to enforce licensing, right? So if the agent is doing something, you need to make sure that, hey, this is your customer. The customer is doing something, so the customer needs to stay within the licensing limits. So you need to see to which service they are subscribed and how much you need to charge them for that. And finally, yeah, you need to make sure that all the customer data is actually preserved and preserved securely. So we will be using Windows Azure Blob Storage for that, and we'll talk about how you do that in a multi-tenant environment. So how do you make sure that even if the agent is compromised, say one of the organizations, your customer A, they have whatever they have an admin who is a bad guy, and that admin reverse engineers your agent and does all the bad stuff. So how do you make sure that that guy, even when he knows all your code, cannot access storage that belongs to someone else, right? Because it's one thing if this guy damages the data of that company, maybe they shouldn't have hired that guy, right? But if he damages data belonging to other customers, then you don't want to have that conversation with them. So if that is clear, we can probably just go and see how that works. Everyone's okay with that? Good. So the first demo is going to be that sign in to the portal, and we'll be using regular Windows Live identity services. Quick show of hands: who has ever programmed against Live ID? Okay, so we have one person. Cool. So I'll try then to show some of the things of how that works. I won't go too deep into that because it's not really new, and most of the APIs are the same and have been the same for probably the last couple of years. It's just that now it's part of the overall story. Oops, and we don't have internet here. Awesome. Okay, I guess that's why you need. That's why we'll be probably switching back to video now. Okay, give me a second, then I'll just. Good thing that yesterday I had similar thing when I was practicing. So when the network came back, I just recorded the video and put it on my USB stick. I wonder if they are turning off wireless just already as they're tearing down the content. Okay, so your experience is going to be approximately the same. I was just recording that yesterday. So and it's going to be even easier for me because I won't have to do any typing. So as you can see, this is, well, just the website. That's going to be the entry point for all of our solutions. And we have added that sign-in button, the standard Live ID sign-in button, familiar to everyone. What you don't want to do is you don't want to force people to click it right away. You want to let people browse your site and find the solution they need and only make them go to that when they actually sign in, when you really, really need them to sign in. So which would probably be that page, right? When they get to the page and they actually decide to start using your product, that's when you need to make sure that they are logged into the site. So they try to click Buy Now. And at that point, you see that this person is not signed in. So you redirect to that Live ID page if the option that they chose is Live ID. And Live ID, I mean, the good thing about Live ID is that almost everyone has it in the Microsoft world, and the whole experience is familiar. So they click that, they sign in, and then you get redirect back. So when you get the redirect back, you again need to see if this is your returning customer and you already have information about that customer, or if this is a new customer. Because if it's a new customer, then you need to do yet another redirect to your registration page and get all of that additional information. So let's see how that actually works in the code and the code behind all that. Okay, so here's my Visual Studio project for the portal. And if we go to the main page, it's going to be a regular ASP.NET page. Nothing really special about it. If I go to design, then when it loads up, yeah, you'll see that we have added this control and the login control, and this control again. The implementation is pretty straightforward. It's just a user control, and what you have here is that basically if the user is not logged in, you make sure that sign in button is selected, and if he or she is logged in, then sign off. And you can add string with the username, with the name of the user if the user is already signed in, and do redirection if they try to sign in from here. What we had in our demo, however, we didn't have a customer click this page. We had them redirected when they tried to make an order. So let's go and see how that worked. So the order page is again a regular page, and in the interesting thing is that line 41. So we, after everything is initialized, we are checking if the user is signed in, and the way we do that is that we have that function that is checking that. And we'll go into that function in a few seconds. But the key thing to pay attention is that you get that current URL and you pass it to that function. So you maintain the so-called context. Context is that URL to which you want the custom to be redirected back once all the registration is done. So you need to preserve it from any page. So let's go and see how this guy is implemented. And the function is pretty straightforward. The only thing is that before doing all these redirects to Windows Live ID, and we are doing them, and as you can see, we keep passing that context so it's not lost. We check if the user is just not authenticated or authenticated but not registered with us, because we are trying to resolve the user, and if the user does not get resolved, if we do not have records about that user, then we need to redirect the user to our registration page. So effectively, this function in our example got called twice. One time it got called for the Windows Live ID, and then when Windows Live ID returned, it got called again and redirected to our registration page. The redirection itself is extremely straightforward. You basically do if you've ever done ASP.NET, it's the standard HTTP context redirect, and then the live ID URL is the URL that I'm sure looks very familiar to whoever used live ID before. You just encode in that URL your application ID, and one thing about Windows Azure is when you register for Windows Azure, they automatically register your solution for Windows Live ID framework. So you get your sign-in ASPX page registered with Live ID, and Live ID just when it knows your application ID, it knows where to redirect people. So I guess key takeaway from that part of the demo is that, let me switch back to the slides. So what we have seen was that whole redirection thing and how customer was redirected, and then we got the customer back. And the key takeaway is that, yeah, from Live ID perspective, if you want to use Live ID as authentication for your Azure application, then all the examples and APIs that were published within last year, they just work as is. And the fact that Live ID is part of Windows Azure framework now doesn't change that. It's kind of standard APIs for that. So the next thing you would do is you would actually get that registration data from the user. So let's switch back to the demos. So we detected that the user is not registered yet, so I have to provide my name and email address and organization and whatever else you decide that you need to collect from your customers. When this happens, you need to store that somewhere. And then, as you can see, the user is signed in, so now we can display the name of the user. And for test reasons, right now we're also displaying the ID that we use internally just to make it easier to debug the stuff. And once that is done, then you can take the user back to the whole ordering page and display your license agreement, prompt for whatever values you need for the actual license. In this particular case, the user is trying to buy our Active Directory backup and recovery tool. So you would probably want to ask the user about the number of user accounts, the number of domain controllers, and how long they would like the backups to be stored. And then you do the regular bill information. So if you want to write down that credit card number, then I can hold the demo for a few minutes. And as you can see, it actually worked. It's amazing what you can do in demos. We are effectively selling the service, the Active Directory backup and recovery service. So you find yourself, when you're developing apps like that, you find yourself in an interesting position that Microsoft is selling you compute power and storage, right? You pay Microsoft for the bandwidth you consume, because your code is running in Microsoft in Windows Azure. So you consume the bandwidth, you consume the compute power, the VMs, and the storage, and that's how they charge you and you charge your customers for the service you provide in a meaningful way for them, because your customer probably doesn't matter how much bandwidth you need for their application. Apart from that, they also pay for the bandwidth for their ISP. Question? Okay, so for the credit card processing, right now Windows Azure doesn't give you like some kind of built-in thing, so we'll be using just another external service. Obviously, you don't want to store credit card numbers in Windows Azure, because you would then need to comply with a whole set of regulations that you just don't want to touch. Other data, like name of the user, name of the company, you do store in Azure. So let's flip the code and see how you do that. So I'll close these guys, and let's go to that register page. So on that page, as you saw, the user clicked the register button, and the code is pretty straightforward. So we are creating that user object, and the user object is go to the code. Oh, that's the page code. If you go to the so that user object is effectively just contain just a set of properties for whatever you keep about the user, and then this line of code is actually storing the data in Windows Azure. That's our wrapper that provides that whole persistence for user data. So if we go into the portal logic, we can see that here's that user class, very straightforward, just a bag of properties. And here's the actual user management class that needs to provide you with the ability to write data into the Azure table and persist it there. And the add user is the method that we were calling that register. So as you can see, basically it passes the call to the to our wrapper against the table, which has a few things. So what we are using when we work with tables, so Azure tables, they expose just regular REST web APIs, so any web application can access them. But if you have .NET background, then you would probably want to go with ADO.NET and Link. ADO.NET works against tables, Azure tables, but not everything works. Like you cannot really do it. Is not a fully functional SQL. There will be SQL data services which will look more like SQL coming within the next few months. Today you are limited to just tables, and you can make queries only within one table, and even within that table, you are limited in what you can do, and I'll talk about that in a little bit. The way you initialize that table management is that you create context and you specify what is your entity, what is your record in that table. And let's just go and see how that user storage works. So the user storage, you use the Microsoft the Azure SDK, which has classes to access tables with ADO.NET, and you obviously need to set up context, and the context is basically just the name of the table and a few other things. As you can see, it's a really simple implementation. And you specify other things such as retry policies. And then you need to implement the actual gets and sets. and it's much Azure tables, they don't have schema, so they are not regular database tables with which you probably have experience working. However, you can mimic schema within ADO.NET. You can create classes that have properties and then write these classes and read these classes from the table and use ADO.NET and link. And in that case, it doesn't really matter to you whether they have schema or not. You still get strong typing and all that stuff that you probably need. So that entity thing is pretty important. So your entity is basically your class that you inherit from table storage entity, and which has the attributes that you want to be written to the table and read from the table. And you can have whatever properties you want, but two properties are mandatory. And these are partition key and row key. So partition key is both of them actually very important when you're designing the table. So partition key tells Windows Azure how to split your data if your data needs to use more than one machine. So suppose you start storing a lot of data and your data storage gets a lot of hits, so then Windows Azure needs to start using more than one machine for your storage. So how do they split that data? They split it based on the partition key. So they think that if different rows have different partition keys, then you don't care whether they are on one machine or multiple machines. So if you never use different partition key for the data that you are likely to want to fetch in one query, because that will make your queries potentially really, really slow. In our case, I'm showing wrong. I'm showing wrong constructor, the default one. We are obviously supplying that, and we are supplying customer ID as partition key, because in most cases our queries will go within one customer data, so we don't care if data from different customers is in different partitions. And then row key is also important, because row key is the ID which Windows Azure Table Storage is using to fetch the data. So that is more or less, not more or less, that is actually the only indexed key in the tables. So you will be basically fetching data based on partition key and row key. Question?
I'm currently building a table storage storage for the kernel system of Microsoft. One recommendation I have, if you're showing that there, is to split off your natural, so if you use the user ID, have the user ID properly. Make the constructor normal, say string user ID, and then just go and initialize the partition key from that value, but keep that property also separate. So make partition key in both just a purely internal affair of storage capacity, but don't have that read out into your app.
Right. So the comment was that a good practice is to further abstract that, so you don't have your app supplying partition key and row key, but that's an internal implementation details and not something your app, your upper level needs to care about, which is a great comment. So once you're done with that, there's not much further that you do, because then ADO.NET actually takes care of the rest. You more or less are then done to just doing add object and save changes. The only other thing that we're actually doing here is that to further abstract storage from the application, the storage is actually serializing that object to XML before writing it down into the Azure tables. So that's just a handy abstraction thing that let the part of our team which is working on the table and storage not care about the actual sets of properties they need to have in their classes. And as I mentioned, when talking about partition keys and bro keys, that querying is absolutely happening based on these. So as you can see, our get method is basically straightforward ADO.NET link get with select and where, and we're using the live ID of the user to get user information and take values based on that. So the key takeaways, I mean, what we've seen was that we got data from live ID. When live ID got us the user back, we got the session cookie, from which we could just, using regular ASP.NET, read the live ID identifier. And then we could use that to persist customer data in Windows Azure table. And we have seen that if you are a developer with experience in ADO.NET and LINQ, then as long as you design your tables properly, the actual gets and sets are quite straightforward. So let's go back to the demo and actually deploy the agent that will be doing something. So the next thing that you need to do is to deploy that agent, and you need that agent to somehow communicate with your main server. You cannot use live ID for that for a couple of reasons. Reason number one is that live ID just doesn't work for rich clients. Live ID currently only works for web applications. And reason number two is that even if it had worked, then what would you do? Supply your live ID username and password and then care about making sure that that password in the agent gets changed whenever you change your password. So it's kind of going to be a lousy experience, especially if you need to share that across your company. So you create a live ID for your agent and then maintain that. So what we are doing is that we are generating a security key, which is basically a GUID for each customer who signed up for the service. And then when you install the agent, you supply that customer ID, that secret key, to the agent, and then agent is using that that key to communicate with your environment. So we supplied that key to the agent. The agent stored that key securely on the computer, and then it could use that key to connect to the service. So we go to different project, which actually has the agent, the client component, and let's see how this is implemented. So the agent which I'm showing in this demo is not the actual backup recovery agent. It's the agent that just tests the connections that can show us the claims that they have and try to store data, get data. So it's kind of demo test agent. However, it works with the real service and is using the real APIs for that. And the cool thing about that is that there's not much that agent actually has. It's more or less the regular Windows Communications Foundation use that the agent employs to get to the service. In fact, the whole agent code is just 250 lines of code. And if we go and see the constructor for the window, then as you can see, what it does is that it creates the proxy object and then uses for the web service, and then uses that proxy object to actually work with the service and invoke methods there. The only thing that is, and yeah, if we go and see the definition, you will see that it's just automatically generated proxy for a web service. It's normal Windows Communications Foundation stuff. The only somewhat interesting part of that is the way that we initialize the connection settings by using Windows Crypto API, so we store that secret key secretly. And another interesting, probably the only other interesting piece of code here is the application config. So this is what we've seen before in the Live ID scenario was passive federation. So the browser went to the service, tried to access the website, and got redirected to Live ID. Here we have Smart Client. So Smart Client, the agent is using active federation. The agent is in charge of actually knowing where to go, what is the service, and what is the STS. STS is the security token service, basically that thing in the cloud, which we'll see in the next demo, that is giving that agent its set of claims, its security context. So in this app config, we have both of them implemented, and so it knows both the STS to which it needs to go to get its set of claims and get its security, and the actual service to which it needs to go after that. So for STS, we are using username and password binding, and it might sound contradicting to what I was just telling a couple minutes ago, that username and password make no sense for the agent, but we actually using that binding does make a lot of sense because Microsoft has implemented it well, and you won't need to be doing much. And what we are using here is that we're using that secret key, which we encrypt and store encrypted on the computer as a username, and then you generate automatically password and keep changing it for additional security, and you encrypt all the communications with your public certificate of your web services. And that gives you a really simple implementation. At the same time, that the implementation is specific to a particular customer. Only that customer has the key for that organization. So their competitors would have different key, and then all the communications are encrypted based on your certificates, the public certificate that you just compile into the agent. What works? Could I explain how password works? Okay. So at the moment in this code, which I took from the main branch some time ago, I think I just use empty password everywhere, and it basically goes down to just no one else has that key as the username. However, in the real production service, when it goes live later this year, I think we will be just automatically generating. There will be initial password, and then we'll be changing it every now and then for additional security. Certs could be another way. We would need to. We would still need to give that cert to that customer as that key. So from customer experience, that won't actually change much. That would be just another secret string that they get from our website and pass there. We will have an option though of Active Directory integrated authentication, which would use then AD certs or just use the token of the local workstation and its registration in AD for the AD integrated option. We have. So the question was of whether we looked at the .NET Access Control service for that. So Access Control service is Microsoft's STS in the cloud, and we found that at the moment it seems to be easier if we implement your own Geneva STS, which would then work against your database and put all the claims in and do the transformation, because it works with your data anyways. .NET Access Control Service seems to be much faster and more performant and scalable than just putting your STS in the cloud. So we might at some point decide that we'll have some kind of hybrid approach. So basically what we've seen in this third demo was that we generated ID for the customer and gave that ID to the client, and then the client could use that ID to access the service. And there wasn't much about the client, which actually is a good thing. It's just normal Windows Communications Foundation stuff, and it works with Geneva, with that new token-based identity framework in the cloud. So time to actually see how Geneva works, because that client needs to go to the STS, to the security token service, get the set of claims about the client and about the access that this client has, and then use that token to present it to the actual service and get access based on that service. Let's switch back and see how it works. So once I start the agent, it actually does go to the. It's a demo agent, so it goes to the service and just asks for its claims and shows us what it has in its token, which is very handy when you demo the stuff and when you debug it. And as you can see in its claims, it actually has all the information about the agent and the customer, which your application then can use for whatever services you provide. And another interesting thing is that we also put a product version into that, so we can then do some kind of staging or beta approach to the new versions, and have some customers redirected to older version of our application and some to the newer version. And also, as you can see, all the licensing information about the services for which they paid and for the counters from the services also in the claims, which again is very handy. You don't have then to do all that license checks throughout your product and services. Question? So the question was, so the customer entered some information on what they want to buy, like whatever number of user accounts they want to protect, or whatever is the counter specific to application, where that gets stored. So yeah, that gets stored in Azure tables, as we have seen in the code. Right. So the question is where Geneva STS takes that. So Geneva STS uses same ADO.NET and LINQ to get to the table and fetch the data. So then, again, we put all of that information in here, as well as actual permissions that you want this agent to have. For example, we had permissions that the agent can, say in this case, get claims, get storage data, create, read, update, but cannot delete. So when we do that, click check permissions here, and the agent, for demo purposes, tries to do all these operations, we get access denied for delete. So let's switch to the code and see how that works. Windows Azure has a couple of ways you can deploy your code into the cloud. You can deploy your code as web role or as a worker role. So web roles are your public endpoints to the internet. They can expose web UI or web services. Worker roles are background services that just run and fetch data and do some kind of processing. So in our case, both the service and the STS obviously need to be web roles, and you're basically just using the when you install Azure SDK, you just get the templates that you use to create those. Inside the STS, there's a couple of things that you need to do. First of all, Geneva Framework samples that are currently published on the internet, they are not compatible with Windows Azure. They will not run there. And this happens for a couple of reasons. Reason number one, all the samples rely on a certificate store, and certificate store is currently not available for Windows Azure code. And reason number two is that all the samples and Geneva SDK, Geneva Framework, they are currently within their bindings. They check for the URL used to access the service, and if it doesn't match, they reject the connections. And the internal URL, the way that machines see it, doesn't match because that's internal Azure stuff, and doesn't match the external one coming to the service. So you need to work around that as well. Yeah. So the question was whether it's a WCF workaround. The address is not matching. The certificates, what you can do, you can either, well, I mean, the simplest thing to do that as a temporary workaround, once the certificate store becomes available, it will probably be a much better option. For now, the easiest thing to do is to include them in the project and just load them locally. That will help you keep you going for now, and you'll be able to get back to the proper way once it becomes available. Other than that, you just go and follow the documentation really, and develop an STS, the security token service that provides all of that security is actually pretty straightforward. You just inherit from the security token service base class that comes with Geneva Framework, and you override just two methods, which is get scope and get output claims identity. In get scope, you just select the way that you are going to encrypt and sign your tokens. So obviously, in our case, we know that these tokens are going to go to our service. So we know who is going to be the consumer of the tokens, the reliant party. So, and we know that we have our private certificate and reliant parties, the service's public certificate. So we're using our private one to sign the token, so that the service can check and make sure that the token comes from us. And we use the service's public certificate to encrypt it. So it's encrypted and only the service can read it. The main method is the get out claims identity, which is the method that needs to put these the actual claims into the token. So this one has the most logic. As you can see, one thing it is doing is that it is just adding all these permissions that get claims, put storage data, update, whatever are the permissions that you just want to generically give. But then, if you recall, we also put into the token all the customer data, and we are doing that here. In that storage helper class and its implementation. And this guy effectively has to work with that same table storage, right? So if you recall, earlier when the customer did all the registration on the website, we put all the data about the customer and the license that they requested into a table. So now all we are doing is basically we are reading that table, and we are getting back from the XML, because if you recall again, we serialized everything into XML just to make it easier for us. And so we are fetching that data, and then we are, once the data is fetched, then we have a bunch of these claims identity adds. So we are adding all that data on the user name, product name, etc., into the claims. So we have two tables. So I was demoing the work of the user with the user table. We have another table which is license table, which has brackets for each customer and for each customer for the products that they purchased. So from this, the license manager is a wrapper, which is like the user manager, just wrapper around a different table. So, but the code inside of it is identical. And the greatest thing about all of that is that once this is done, and this is literally all you need to do within the STS, the cloud service implementation is very straightforward. So within the cloud service, if we look at the implementation of, say, these at the moment dummy classes that are creating, reading, and updating, the whole access check is trivial, right? You don't the service, the actual web service, doesn't have to do any checks, doesn't have to authenticate the user, doesn't have to do much authorization except for just checking the claims. And the claims, the way you check the claims is again very straightforward ASP.NET way. You just check the roles within these attributes. So in this demo, what we have seen was that the agent was smart agent active. So we had seen what is called active federation, in which the agent itself does all the federation work and doesn't rely on the redirects as browser does. However, the STS and the service, both in the web configs, we have tuned them to work with each other. So the STS creates claims and signs the token and encrypts the token for the service, and the service is expecting that token to be from that particular STS. And the STS again was just working with Azure tables to read the data both about the user and about the service that they were about to use. In that case, Active Directory Backup Recovery Service, and all the information about the user, information related to the service and on their access was just put into that token. So then the service doesn't have to care. So the final piece of that demo is to actually get this this agent go to the service and do something. So let's. Oh, okay. And one thing which is kind of a little bit tricky. It's trivial the way you implement that, but it's tricky in the design. And the trickiness is that you have to provide that multi-tenancy. So you have to make sure that your customers, that you separate data from different customers in a way that no matter what a particular customer does with the agent on the customer side, this customer cannot do any damage to your overall structure and for the data to the data from other customers. And so that means that you should never ever let the customer-side agent work directly with the storage. Because the way you work with the storage, with Windows Azure Storage, is that when you register as a developer for that storage, when you register your application, you get the keys, you get the token for that storage. So your code working with the storage is supposed to have that token. That's the only way the code can access the storage. The problem is that that token doesn't have any, there's no inherent delegation within the token. The token gives full access rights to that storage. So if you put that token into the agent and someone figures out how to use that token and extract it from the agent, or your agent just has a bug and tries doing something wrong, because, I mean, that never happens to Quest products, but some products out there from other companies might have bugs. So you want to be absolutely sure that this thing doesn't have that administrative control over your whole storage. And the way you do that is actually using, the way you work around that problem is by making sure that your service is that proxy that works with the storage, and it picks the specific part of the storage, the specific blob, based on that same claims in the token. So in that sense, Geneva and multi-tenant storage, the Azure storage, actually better together in a big way, because they it would have been really hard to implement that multi-tenancy should you have had to done that on your own. So let's switch to demo and see how that actually works. So go back a little. So we have seen how we saw the claims and tried the claims, tried to get access, checked the permissions, and saw that access was denied for the methods which we didn't have rights to do. Now we can actually write some data, and we can put the data and get the data. So if we had the internet running at the moment and available, then we could have tried doing that from 2 different computers using 2 different keys and see that the data that we get back is independent and different. Now with only 1 demo available, you would kind of have to believe me for the moment and then see the code in a minute and see that, yeah, the code is actually implementing that multi-tenancy. So let's go to the code. So yeah. So I maintain credibility, I guess. So one thing that you could have found a bit weird in the client was that if you recall what the client was doing when we were initializing the window, was that the client actually had show claims method, which was actually getting the claims from the service. Does it look weird that the client needs to go to the service and ask about its claims, or is it like natural? Shouldn't like the client know what claims it has? Yeah, exactly. So the answer is that, yeah, that's the federated security model. The client actually has just that piece of bits, right? Just zeros and ones, and it's encrypted. So the client doesn't know what it is passing further. It's just getting that token from the STS, from the security token service, and just goes to the actual service and says, yeah, here, have it. That's me. So then, for our demo purposes, when we wanted to display the claims, we have that get claims method, which gets invoked on the service, and what it's returning is basically just an array of strings then the client demonstrates. That's not really a product feature, just a demo feature, which makes it handy to demo them and display them. The actual work with the data is obviously happening with these get data and set data methods, which again are calling the methods in the cloud that's working with the blob storage and passing just the content. Again, you don't have to implement passing the token. WCF will do that for you. But on the service side, you obviously have to somehow use it to make sure that proper access is maintained. So let's go and see how this is happening. So here's our cloud service web role, and within that role, we have implemented storage access. That storage access have these put blob block and get blob block data. And within this code, it's actually hard to see where multi-tenancy is implemented. As you can see, we're just getting storage and then putting data into that. So how does it know where to put the data and where to get the data, to which customer the data belongs? This is actually pretty trivial because when this storage object is created, the storage provider is in charge of locating the partition for that. And again, you can think of a partition for blob storage as just different databases, in the sense that each partition is a different set of blobs, different set of data that you can put and get. So that partition provider, all it does is that it gets the current from the current thread. It gets the current principal, which is a ASP.NET way of detecting who the user is, who is accessing you. Only in that case, it's actually an agent, not a user. And then you cast it to the Geneva extension of that, to iClaims principal. So that's your Geneva identity, which after that you can enumerate claims, or you can use LinQ to locate a claim of specific type. In which way we get the name of the company, and for the name of the company we then just calculating the hash, and we're using that hash as the name of the partition. So once you've done that, you just work with that storage. You just invoke put blob block on that storage, and which is a standard method. So I don't have a source code for it on this machine. So the whole multi-tenancy then becomes actually really trivial, because again, whenever this agent comes to you and invokes your methods, it has the token with it, and you can cast it to the iClaims principal and get the data and see the partition. And by definition, that means that you have your customers separated, and each has its own partition, and the agent just cannot access someone else's partition.
Unless the company name happens to hash it.
What's that?
Unless you happen to generate the same hash to it.
Right, which cannot happen, because that's the way that hash is implemented, that it's uniqueness. Go back to what? Okay, yeah, sure. Yeah, you use that as partition name. So when you store the data in a blob storage, you provide you need to, each time you put the data, you need to put it in a specific partition, and then blobs within that partition. Let me see if I have that, because most likely I just don't have the code on that machine, because that's just Azure code. Wow. It looks like that. I mean, we just didn't even have to. We just didn't even have to override that. So it's yeah, it's just a ADO.NET method that you call, and because you supplied the partition provider to it when you were initializing the object, and it's now using that partition for all the where calls and all the puts. So in that last demo, what we have seen was that we were creating separate blobs, separate partition blobs, separate blob partitions for each customer, and then we had the storage service just using the information from the token to initialize the connection to the proper partition, and so the claims were used to provide that multi-tenancy. So to recap the whole scenario, we have seen actually quite a bit, and the functionality that we have seen in this scenario is not trivial at all, but was actually relatively straightforward using the new APIs in Windows Azure. So we had a lot of technologies used. We had Live ID used by the human being, by the actual customer, to identify himself or herself, himself in my case, to get to the website, register with us, and make sure that we then provide all the relevant UIs, and we recognize when the admin comes and logs on to the service. We had all the registration done and customer license and info kept in Azure storage. We did the agent deployment and secure communications between the agent and our service, and our STS, again on Azure, helped us make sure that we control access and provide it securely and in a multi-tenant way. So quite a lot of different functionality, and all of these Microsoft technologies actually working best together. Now, questions? Mm-hmm. Right. So the question was that blobs are great if you just like put a lot of data. Here's a lot of bytes that I need to store. How do you put metadata there? If it is a backup and you need to know when the backup was taken and whatever is probably some kind of index for the backup, whatever needs to be there. So blobs actually have metadata associated with them. So when you're writing a blob, you can write metadata with it. And I don't remember the size limit of that metadata. I think it was like 4 megs or something. Less, whatever. So, some kind of number. Whatever. There's a way. So a blob, I think, can be up to 50 gigabytes. And then there's a metadata that you can put with it, which can contain your random properties. So that the question is that then you can use that metadata to search and do your queries. Actually, the answer is no. You cannot do queries against the properties in that metadata. So you would need to implement that somehow yourself. So you would probably want to have pointers to that in, say, some other table, or maybe even better, if you need to search against multiple properties, then today you would probably have to merge them into the keys, the row keys. In the near future, when SQL data services become available, you'd probably use SQL data services so you can do real queries and then fetch the point to the. So the question is that at some point you would need to then create your own index and do hashes and do that. Okay. So the question is where's then when does Geneva and then Quest service starts? So Geneva is a lot of things, right? Geneva is a set of technologies. There's Geneva framework, there's Geneva server, and Geneva card space. Card space is the thing that you can get on the client, asking you to pick the right card. Geneva server is Microsoft's implementation of STS that you can install on-premise, for example, to federate with another company or to connect to the cloud. Geneva Framework is a set of APIs that you can use to build your own STS to work with the claims. So we use that set of APIs, of Geneva APIs, to create our own STS and host it in Azure. Mm-hmm. Right. Right. So the question is, where are they? Yep. Yeah. So these are them. So the cloud service web role is the service that's doing all that stuff, and the cloud STS is the STS issuing the claims. So within the cloud service, we're looking at the storage access and on all these methods that were just doing something and having permissions checked for them. The STS was the project that was in which we saw the generation of the claims. Okay, so I see some people leaving. Please fill out the evaluation forms. We need to have at least 10 of them to get me evaluated, so every form counts. If you want to follow up with me later on, I'll be on Lufthansa flight from LA to London later today. Going to the question on where you get them. So the client, all that the client has in its work with STS is the app config file that tells the client that it needs to get the services get the token from the STS, and the client that's it. Like the client doesn't work with claims anymore. It just gets the token and then uses it to access stuff. And on the actual service side, we do need to know what the claims are, and we were using them obviously to check whether the client can use the methods, and we also were using them to find the right petition and stuff. So the question was that, so WCF is orchestrating that whole thing, passing talk. Yeah, that all is handled by WCF. So, yeah, thank you.